We are on page 421. We're going to go over chapter 10 right now. And I'm not going to lie to you, 9, 10, and 11, not only are they the hardest chapters in the book, they're the driest chapters in the book. It's not exciting stuff. All right? And with many of you, you know, it's funny because I had one of the second-year students came up and talked to me and said, you know, between the object-oriented stuff that we did at the end of the second semester and the ASP.NET class and the Java class I'm taking now, he said, it's convinced me that if I have a future in IT, it's as a web developer. Because I get that a lot better than I get the programming stuff. Fine. And there's plenty of jobs out there for that. Some of you may like this. Some of you may not like this. All right? So when we look on page 421, and again, I'm not going to read these to you, but they have the different objectives for the chapter. I would say even more than describe inheritance, be to understand inheritance. In many ways, inheritance is like genetic inheritance. And I've given you this example before. I have said that typically, if you have a man and a woman who get married and have a child, bless you, typically if they both have a big nose, the child will have a big nose. Some people say, that's really a terrible example, and you're criticizing people with big nose. I'm not. I'm not criticizing anybody. But what I've said is it's not like that person can take their nose off and put another one on. But that's what you can do with inheritance. So what you'll see tomorrow is we'll say, hey, all employees have this in common. All right? So what we'll do is we'll create that employee class or change it. So, you know, we got that. Then we'll start creating employees based off of that, or classes based off of that class. And, for instance, all employees in an ideal world are going to be able to get paid. But the way they get paid is different around here, all right, or around most companies. And like I gave you the example, an hourly worker versus a commission worker, etc. All right. We will talk about abstract classes today and tomorrow. We'll talk about interfaces today and tomorrow. And, you know, I've said this kind of thing to you before, but I want you to know this. Virtually everything that you learn in here, when you've got your class in the 4th semester, so a year from now, we've knocked it down. You're going to get about 2 weeks of really intense Java. Really intense. It's going to be almost this same exact stuff all over again. The syntax is a little different in Java, but the logic and everything is 100% the same. All right. So they do mention here on the next page, all object-oriented programming languages make use of inheritance. And they do it for the same reason. So that you're not always recreating the wheel. All right. So you know this is going to make its way onto your test. Because they've got, you know, says it's the principle that you can apply to your knowledge. Yeah. But you will be asked on the test, someplace in there, what is inheritance? All right. So what do they use? Well, some of this stuff isn't going to be that different from what you just saw. All right. I just went over a fairly detailed example with you of an employee class. Sorry, I can't really shut that because it's too frigging hot in here. All right. But it says, consider the employee class in figure 10.1. The class contains a field for the salary as well as 2 properties. All right, ID num and salary. The ID num is an auto-implemented property. The salary is not auto-implemented. It is created manually. What does that mean? Well, look at this. Ideally, at least, you can look at this thing that's on page 423 and figure it out. All right, we're assuming an employee. We're not worried about names or anything like that. Each employee has 2 things. They have a salary and they have an ID number. The ID number is a simple getter and setter, and the salary, you have to do some validation. That's it. Now, why they go and throw in this goofy, stupid get greeting method is above my pay grade. I don't know why she does that. All right. But the important part is, now notice what we have. This is creating or instantiating two employee objects. One of them is called receptionist. One of them is called delivery person. But each one of them, because they're both employees, each one has an ID number and a salary. You start to realize how this breaks apart when you've got different types of employees. Because different types of employees at companies are handled differently, not just paid differently, but everything they do, their job assignments are different, etc. So here are some of the benefits on page 424 at the top of the page of using inheritance. I don't want to read it to you. The biggest thing is code reuse. Code reuse will save a company money because rather than having to invent something new, they can use something they already have and modify it. I may have told you this example the other day. I don't remember, but just as an example. All right, so sorry if you've already heard it. Let's suppose that I get contacted by Holiday Inn, and they ask me to create a reservation system for them. All right, people can check in, check out, etc., pay, all that good stuff. I get it done. Then I get a phone call from Enterprise Rent-A-Car that says, well, we also want to redo our reservation system. It's really not that different from Holiday Inn, except instead of getting a room, you're getting a car, but most of the other stuff is the same. Well, if I build it the right way, I should be able to take that reservation system and modify it or extend it, or have a child of it or whatever, and I should have one system maybe that handles cars, another one that handles hotels, maybe another one that handles something else. That's what they're talking about right here. Now, a little bit of terminology on the bottom of page 424. I showed you that before where we had employee. In fact, let's look at animal. And underneath it, dog, cat, and bird. All right, animal is called a parent class or a base class. Okay? And the other ones that we created under it, the dog, the cat, and the bird, they're called derived classes or child classes. Sometimes a parent class is called a superclass and a child class is called a subclass. A class can be both a superclass and a subclass if it's in the middle of a class hierarchy. The class at the very top is called object. All right, so anytime you create your own class, it automatically inherits from object. Why is that important? Because one of the things that object has is a two-string method. That's why you've overwritten your two-string method, but it was there to begin with anyway. All right. They also use this, a couple things here. And they're talking about how to figure out when you're doing this, what are you doing? The big thing is inheritance is a relationship. So again, if I come up here and I've got animal, and then underneath that I've got dog, cat, and bird. A dog is an animal, a cat is an animal, a bird is an animal. When you have an is-a or an is-an relationship, you have inheritance. All right? They also mention here another way you can do it. It says if you want to talk about a parent and a child and you want to know which is which, all right, it says the order matters. What makes more sense, an evergreen tree or tree evergreen? Well, in my opinion, an evergreen tree makes more sense. So it's child, parent. What's going to happen is you create a parent and then you create a child off of the parent. Here, I'm asking you this question. You can guess if you don't know. But if you've got a parent like animal and you've got a child underneath it like dog, which one do you think would be bigger in size, and why? How many people think the parent would be bigger? How many people think the child would be bigger? Wow, nobody's raising their hand for either one. Okay, Christian did, and he's right. The child would be bigger because the child has everything. It inherits everything from the parent and then adds its own stuff. All right? All right, for instance, if I had a dog class, I might add a new method called wag-tail. Wag-tail probably wouldn't make a lot of sense for a lot of other different kinds of animals. All right? All right, so when you do this, you are doing what's called inheriting or you're extending classes. This should by now make sense because you saw that where we had the name of our bank account and we had yesterday I comparable. So you've done that a little bit already. This says commission employee is a child of employee. That's how you read it. And I think I've even mentioned this to you before, but when we get into the Java, you won't have that. You'll have the word extends. Other than that, it works virtually the same way. So when you look in here, so what's the difference between an employee and a commission employee? A commission employee has a commission. So notice they have a commission rate. So they come in here and they start to build that class up. Okay, they mentioned this, and I just want to say it to you. They talked about stuff being transitive. Does it make sense to you that if I've got a class here that I create that's called employee, and then I've got another one I create underneath that called commission employee, let's just quickly make another one that says we also have employees that are piece workers. Does it make sense to everybody in here that every commission employee is an employee, but not every employee is a commission employee? Does that make sense? Because in the book they talk about it being transitive, and that's what they mean. In the same way, every piece worker is an employee, but not every employee is a piece worker. All right, just in the same way, I'll take your question in a second. Everyone in this room, you're all IT students, but not everyone in Rankin is an IT student. Yes?
So if you had a layer below that, if you have someone that's also like two the one above it?
Yeah. You mean like this?
Yeah, or like they're like joining back together. Like instead of breaking off that.
I don't know if this is what you're asking, but you can't do that in this language. All right? And I shouldn't even say it like that, but what I'm saying is this. You can't have, it depends on exactly what you're asking, but one class cannot have two parents, if that's what you're asking, because that's multiple inheritance. There are very few languages that allow that. One language that does is C++. That's why a lot of people hate it, because it allows you to do that, and it makes the language much more complex. The way you get around that is instead of creating classes, you're going to create what we're going to talk about a little bit later in this chapter, which are called interfaces. All right? Now, this page just looks like somebody threw up on the page here, on page 427. And she's just showing that she's making what? Two employees that are of type employee and two employees that are of type commission employee. And she shows all the different stuff that you can do with them. I just found that unbelievably complex and, for lack of better words, irritating. When they say it works in one direction, it's what I told you before. Every clerk is an employee, but not every employee is a clerk in this example that they show here. And that's what they mention here. All right. And again, there will be something that all employees have in common. Whatever it is, there will always be something that they all have in common. All right. Then when you look on the bottom of page 429, and it goes on to 430, 431, and 432. You've heard me say this until I'm blue in the face. But if you're struggling in here, at least, if you're not going to read the chapters, at least look at the you do it's. They explain how things are done. All right, again, it's the old saying, I don't know if you've ever heard this before, how do you know if somebody's a good speaker? 3 things. They tell you what they're going to tell you, they tell you what they told you. That's exactly what she does in these you do it's. She explains what she's going to do, she does it, and then she explains to you what she did. So again, if you're struggling, I would strongly suggest that you go and take a look at them. All right? Yes, sir. You what? Yeah, very possible. Yeah, I mean, if you want, I can contact Thorne and find out how many people are coming.
No, that's right. I'm just trying to find a site.
Well, I mean, if I could get them by the 7th, then I would copy everything over there that night.
I'm looking to try to get them by the 4th or so.
Oh, that'd be great. Thank you. All right. So far, when we talked about these access specifier, let me ask you a question. Do you think you have an understanding of what public means in our programs? Did you notice that anything that we made public in our bank account class, we could call directly from Maine? Did you notice that? All right, because public means it's available everywhere. Private doesn't work that way. Anything we created private, all right, in our bank account class, if there was a method, I don't think we had any, but if we had any private methods, they could only be called from within that class, not from outside of that class. Sometimes, though, what happens is you've got a hierarchy like this. And so you've got a parent and you've got a child, and maybe you've got a grandparent, a parent, and a child. And maybe you've got something that you want one of your descendants to be able to change. Did you hear what I said? Then you make it protected. All right? Years ago, when they were figuring out this object-oriented stuff, somebody came up with the idea of protected. A lot of people think that protected shouldn't even be allowed. That the only thing that should be able to change something is the thing that made it. All right? It would be like, if somebody decides that they're going to change my last name, and from then on, everybody's is going to be, not because they get married, just because they think that Scott should be spelled with 3 T's. I don't know why, but they do it. When something's protected, that means that's what you can do. That means the parent can change it, and any descendant of the parent can change it. That's what protected means. All right? That will make its way, I'm sure, someplace onto your test. When we get done with this, we are going to go over the review, and I am going to give you the study guide. All right, we'll do that afterward. But in a nutshell, I just gave you what's there on pages 432, 433, and 434. In fact, the author summarizes it on the bottom of page 433. Again, it's not my goal to read to you, but they do explain the problems with public and private and why you might want to consider protected. All right? But even if you do, the number of fields or methods that you make protected, all right, always should be minimal. Because some people think, I'll just make everything protected. No, that's a really, really bad way to program. All right? It's kind of like saying, this is the way my house is. Right now, I've got a 27-year-old living with me. It's my daughter. And it's like yesterday. I went and got my taxes done. She texted me, would you stop at Wendy's for me? And I said, yeah, but I forgot. All right? So she went out there herself at 7 o'clock at night, slammed the door when she left. All right? Because she thinks that, it's like, why can't he remember stuff like this? Well, he's getting old and a lot of other things. But in many ways, she feels that she's better than me. And that's the problem that you get with things that are protected. you've got classes that are down the hierarchy tree that change things that probably really and truly shouldn't be changed to begin with. So they show you, and if you look in here, if you look at the top field, that's salary, and that's protected, which means it can be changed here and in any class that extends this class, or any child class. That's what it means. So tomorrow what we're going to do is we are going to go and add at least one more class. We might add two more. I don't know. And the author uses some terminology on the bottom of page 435. It says classes that depend on field names from parents are said to be fragile because they're prone to errors. They're easy to break. Well, I don't know how true that is or is not, but by making everything protected, you're asking for trouble. All right. All right. The next thing that's in here talks about overriding base class members. All right. And it says you first learned about the term polymorphism in Chapter 1. It means many forms. Yeah, that's fine. But if you look in here, in fact, 2 or 3 of the questions at the end of the chapter in the review are like this. All right. Although both a drum, for example, and a guitar are musical instruments, when you say play a drum, you don't play a drum the way you play a guitar. You wouldn't strum a drum, rather. You wouldn't start beating on a guitar with drumsticks. All right? But they both could react to a play method. And if you program them correctly, they both would react correctly to the same method based on the type of object they are. All right? There's other examples in here too. So then they go in and they create this student class. All right? And you can see when you look in here, you might notice that what do we have? Well, we've got this rate at $55.75. We've got credits, we've got tuition, we've got name. And the bottom line is this. I think you'd all agree with this. The chances that everybody in this room right now, you're all in this class, but the chances that you're taking all of the same other classes is probably pretty remote. Some of you may have already taken gen eds. Some of you may be taking one gen ed. Some of you may be taking multiple gen eds, etc. All right? And that's kind of what they're getting into in here. By saying that this thing is virtual like this, what you're saying is as the program's running, I'm going to let you figure all this stuff out because it's going to be different for everyone. And that's not, I mean, that is pretty much reminiscent of the way real life is. I don't believe that everyone who works at Rankin, all instructors, I don't believe we all make the same amount per hour. I could be wrong about that, but I don't think it's like that. I don't think Mr. Corrigan would like it that he's been here almost 30 years, and if somebody walked in the door, they'd be making the same amount he's making. I don't think he'd think that was fair. But there are companies that are like that, all right? Especially when you do have companies that work, that on an hourly basis. Sometimes they're like that. Sometimes if you're a piece worker, it's like that, all right? So as it says here on the bottom of page 437, it says credits is declared to be virtual. Again, a virtual method is one that can be overridden. All right? It's saying it's like a protected method. All right. And it says in Chapter 9, you learn that when a method overrides another, it takes precedence. So in other words, if I create something in employee and I overwrite it down below in commission employee, that's the one that gets used for commission employees. All right. Anybody remember this? This override? That's what we used with toString. We used an override. All right? With the toString method. What that means is, rather than using the typical toString method, if the toString gets called by my program, use this one. And as they mentioned down a little bit below that, it says basically the child hides the parent. Okay? So sometimes, okay, the child hides the parent. What if you want to do the parent thing and not the child thing? Remember this word? Remember that? If you say super in most languages, it means use the parent. Don't use the child. Not exactly the way it works here, but you're going to see how it works here in just a couple minutes. It says a base class member that is not hidden is known as visible. So visible and hidden. Two more words that very well could make it onto your next test. Okay, this again, I don't understand some of her examples. Look, Luke, you made it into the book. All right. But if you look right here, there are some schools that allow you to audit classes for free. Well, it would be much different figuring out the cost that you pay per semester if you could audit everything you're taking. There would be no cost. All right. In fact, at the school I used to work at, what they did was they announced that everybody who was over 50, they considered them to be seniors, and they allowed them all to audit classes for free. Then the problem that they had was in some of their classes, especially their night classes, they were getting filled up with people over 50 who weren't paying, yet they had to pay the instructor. So they changed it so that instead of you having to pay full price, you paid half price. Then not that many people signed up after that. All right. So the author says, notice if in a method header you use the keyword new, when you try to do one of these overrides, you may get warnings. You may have to put that word in there to make the warning go away. You're going to see that again as we continue on with this. But this right here, they don't use the word super in this language. They use the word base. Base means parent. All right. Again, on the bottom of page 440, and it goes on to 441, 442, 443, and 444. All right. Notice it says, in the last you do it, you created a loan class and a car loan class. Now you've got new bank rules. So they go in and they come in here and they add a protected variable. All right. And they run not the same program, but in many ways the same program. All right. All right. Moving up to page 445 here, the author talks about implicit reference conversions. You may or may not remember this. We talked about it before. If something is done implicitly, it means it's automatically done for you by the software. All right? And that's what they're talking about here. It says every derived object is an instance of both the derived class and the base class. It's what I told you before. So if you create a type of dog, it's not only a dog, but it's also an animal. Or in this case, it's also a mammal. All right. So when you look right here, again, a commissioned employee is an employee. So anything that was defined for an employee that's public can be used directly by a child. And that's exactly what they're doing right here. All right. I mentioned this to you before, that object is at the top of everything. So if you look up on the screen here, we did this thing before. Wrong one, right here. We've got this public employee. Everybody see this? You don't do this, but literally what the system does for you is this. Okay? You say, well, it's got all these errors. Don't worry about that. What it's saying is all classes that you create, in fact, I put it under the constructor, and that's why I'm getting all those errors. When you create the class, that's literally legal to do. Because if the class doesn't have a parent, its parent is automatically object. You wouldn't do this because it's redundant. It basically is done for you. But you could do it. Notice, no errors now. All right? Would you ever want to do it? No, because it's redundant. What does it give you? Everything that the object class has, you're able to automatically use. Is that important? Yeah. Why? Well, two reasons. One reason is because, see this stuff right here? That's on your test. All right? These are the things, on your written test. These are the things that are automatically provided to you, all right? That are automatically provided to you, these 4 different methods from the object class. So any class has access to these. All right, doesn't matter if you're a child, a grandchild, whatever. You all have access to an equals, get hash code, get type, and toString. The only one we've dealt with in here has been the toString. But they do give you examples on the next couple pages of the get type. So if you wanted to know if something, for example, is a type of employee, you could use the get type. The get string, again, we've already looked at. And they've got an equals example in here. And they also have an example of the get hash code. We're not going to cover any of those. All right. Turning up to page 452, they talk about working with base class constructors. All right, I'm just going to draw something on the board. I'm hoping it helps, but we'll see. So we just looked at that employee, and we said every employee had a first name, a middle initial, a last name. In fact, we'll do our own. We'll have an address, a city, a state, and a zip. We'll just leave it right there. So we're going to say every employee has that stuff. All right? Now we come in here, we create an hourly employee. And an hourly employee has all of that stuff. Okay, so it has the first name, the middle initial, last name, address, city, state, zip. But it also has an hour's work, and it has an hourly rate. Okay? Then we create another class that's called commission employee. And a commission employee has a commission rate. You see the difference between these 3 classes? Do you understand, though, that all 3 of these classes have this stuff? So when I create a constructor for this one right here, this. So if I've got a full R constructor, it's going to say public hourly. And then it'll have in here, string, first name, string, or char, whatever it is, middle initial, string, last name, string, address, string, city, string, state, string, zip. All right? But my hourly employee will also have a double hours worked and a double hourly rate. What I want you to understand is the parent has got to handle this, 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 and this. The child only handles the stuff specific to it. And how is that done? Well, that's what's shown next in here. All right. Yeah.
What's your first one? Can you tell us how many minutes ago?
Sure. And
with Brandon?
You're in the wrong building.
Oh,
He's
okay.
the other building that's that's connected to here. It says Larry Elms Training Center.
Uh-huh.
All right, if you go there, Brandon's office is right there. Right when you
Okay.
go in, you walk in and make a right.
Okay. We're in the wrong building, guys.
All right. If we look, starting on the bottom of page 455 and going on to 456, this is what I want you to see. Okay? What this says is, okay, whenever I call a car loan, I get passed in a number, a name, an amount, a year, and a make. But by saying colon base, that means I want loan, which is the parent of car loan, I want loan to handle the num, the name, and the amount. The thing that's special just for a car loan is the year and the make. Because if I was going to get a home loan, year and make wouldn't make any sense. All right. So it's that colon base that you see in there. You will see this tomorrow. All right, when we go through our next example. All right. Before we go into abstract classes, and it hasn't been that long, but like I said, I realize how dry this stuff is. So it is 9:43. I'm just going to be short. I'm going to give you till 9:55, and I'm going to start up and I want to finish the chapter. All right? So please be back. I'm going to start right up at 9:55.